Download this code and get free GPT-4o from codegive.com, link in the description below. ## Understanding time complexity in Java. Time complexity is a computational complexity that describes the amount of time it takes to run an algorithm as a function of the length of the input. It's a crucial concept in computer science and helps to evaluate the efficiency of algorithms. ### Big O notation. Time complexity is often expressed using Big O notation, which categorizes algorithms by their worst-case scenario. Here are some common time complexities. O(1) Constant time. The execution time does not change with the size of the input. Log n, logarithmic time. The execution time grows logarithmically as the input size increases. N, linear time. The execution time grows linearly with the input size. N log n, linearithmic time, common in efficient sorting algorithms. N superscript 2, quadratic time. The execution time is proportional to the square of the input size. 2(n), exponential time. The execution time doubles with each additional element in the input. N factorial time, grows very quickly with the input size. ### Measuring time complexity. To analyze the time complexity of an algorithm, you can count the number of basic operations the algorithm performs as a function of the input size. ### Code examples. Let's look at some simple Java code snippets that demonstrate different time complexities. ####1. 1. Constant time. ####2. N, linear time. ####3. N(2), quadratic time. ####4. Log n, logarithmic time. ####5. N log n, linearithmic time. ### Conclusion. Understanding time complexity is essential for writing efficient algorithms. By analyzing the time complexity of different algorithms, you can choose the most suitable one based on the constraints and requirements of the problem you're solving. Always remember to consider the input size and the nature of the data when evaluating performance.